Hi everybody, Mrs. Danielson here, and today we're going to talk about the unit circle. In particular, we're actually going to derive the unit circle. This is a moment everyone looks forward to in pre-calculus, the day you have to derive the unit circle, and that's what we're going to work on today. So let's go ahead and switch over to my iPad and let's get started. We're going to derive the unit circle, a big moment in our pre-calculus careers. Here we have a blank unit circle. And we're going to start by talking about the fact that in a unit circle, your radius is 1. So let's start with that fact. Our radius is 1. And what that means is that on the x-axis, our coordinates are going to be 1 and 0, and -1, 0. And on our y-axis, we're going to be at 0 and 1, and 0 and -1, right? We just get that from the fact that on a unit circle, our radius is 1. All right, we've already got stuff on there, right? That was easy. Okay, now let's talk about our angles. We can go in and fill in some of our angles. Right here, we're at 0 degrees. And up here on our y-axis, we're at 90 degrees. Over here, we're at 180 degrees. And down here, we're at 270 degrees. Okay, we're just going to continue to fill in some of our angles. That would make this 30, 45, and 60 degrees. Okay, let's fill in our angles here in quadrant 2. 90 degrees plus 30 degrees, that would be 120 degrees. This would be 135. And that next angle would be 150. All right, our angles down here in quadrant 3 would be 210 degrees, 225 degrees, and 240. Okay, and our angles in quadrant 4, right, 270 and 30 degrees would be 300 degrees. Oh, that's 300 degrees. Okay, 315 degrees, and then add 15 to that, 330 degrees. And then we're back around to 360 degrees. Okay, now all those degrees also have radian equivalents, right? 0 degrees is going to be 0 radians, and 180 degrees, that's the same thing as pi in radians. 90 degrees is half of pi in radians, pi over 2, and 270 degrees is 3 pi over 2, 1.5 pi in radians, right? Now for the other ones, right, we already learned in a previous video how to convert from degrees to radians, right? You just take the degrees, say 60 degrees, and multiply by pi over 180 degrees, and then you simplify, right? So this is going to be 6 pi over 18, and then you reduce. So 60 degrees is pi over 3. And you can do that with the rest of those, right? So we can fill in our unit circle with all the degrees, and they're equivalent in radians. So 30 degrees is pi over 6 in radians, and 45 degrees is pi over 4 in radians. And we can do that for the rest of this unit circle. 120 degrees, when you convert that to radians, is 2 pi over 3. 135 degrees is 3 pi over 4. 150 degrees reduces to 5 pi over 6. 210 degrees is 1 pi plus 30 degrees, right? So that ends up being 7 pi over 6. 225 degrees is 1 pi plus another 1/4 of a pi, which is 5 pi over 4. 240 degrees is 1 pi plus 60, right, which ends up being 4 pi over 3. Okay, now we're moving over here to the 300, right? That's 2 pi minus 60, right, or 300. And then we do our conversion, right? And when we simplify, we get 5 pi over 3. Okay, and we do our conversion on 315, multiply 315 by pi over 180, and then simplify. And we get 7 pi over 4, that's a 7. Okay, and then 330 ends up being 11 pi over 6. Again, we've done these in a previous video, just simplifying degrees to radians. And 360 degrees is 2 pi. Okay, now let's get down to the real juice here of the unit circle. What the most important part here of our unit circle, and that's the coordinates. Okay, these spots here on the edge, these are called terminal points. Okay, right here on the edge around the ending points on our unit circle. Okay, I'm going to start right here at this one. Okay, this one in the terminal point for 45 degrees. Okay, that 45 degree point is right here. It's on the end of a 45 degree angle, right? We have a coordinate right here we're interested in. Okay, normally a 45, 45, 90 degree triangle looks like this, where the ratios of the two legs are 1 and 1, and the hypotenuse would be the square root of 2. Okay, that's just a special 45, 45 degree 90 triangle. Okay, now on this unit circle, the hypotenuse isn't the square root of 2. The hypotenuse in a unit circle is 1. So to make this hypotenuse, or this radius, 1 instead of the square root of 2, I divide it by the square root of 2, right? Because the square root of 2 divided by the square root of 2 is 1. But I can't just divide that by the square root of 2. I have to divide all 3 sides by the square root of 2. Okay, and what I end up with is a little bit different triangle, right? My sides are a little bit different. Okay, so this is going to be a 45, 45, 90 degree triangle that would be on the unit circle, right? Because now I have a radius of 1. Okay, and 1 divided by the square root of 2, well, I have to kind of change that a little bit because we don't like having the square root of 2 on the bottom, right? So that ends up being the square root of 2 over 2, and the square root of 2 over 2. Okay, so what would now be the coordinates there on the edge of my unit circle? What is my x? Well, my x right here is the square root of 2 over 2. And what's my y? Well, my y is the square root of 2 over 2. And again, I got those by changing that radius, or the hypotenuse, from the square root of 2 to 1. Okay, so now I can come back up to my unit circle, and I can change here my x and my y to the square root of 2 over 2. Okay, so that's my terminal point for 45 degrees. Square root of 2 over 2 and the square root of 2 over 2. Okay, now 3 pi over 4, or 135 degrees, right? This angle right here, 135 degrees. Well, it has a reference angle of 45 degrees. Okay, so its x and y coordinates are also going to be square root of 2 over 2 and square root of 2 over 2. Same thing, the same x and the same y, right? Square root of 2 over 2 and square root of 2 over 2. Only there is one thing that's different. And what's different about it is the fact that in quadrant 2, the y is positive, but the x is negative. So that means that my coordinate is actually negative square root of 2 over 2 and positive square root of 2 over 2. All right, so we use the fact that we know the reference angle for 135 degrees is 45 degrees, and just move those two coordinates from quadrant 1 to quadrant 2 and change the sign on the x to negative. Okay, we can do the same thing now if we look at quadrant 3. In quadrant 3, okay, the x and the y are both negative. X and y are both negative. Let's make those red so they stand out a little bit more. Okay, and if I take a look at this 5 pi over 4, or 225 degrees, that angle has a reference angle of 45 degrees. 225 degrees has a reference angle of 45. Okay, so 45 degrees has an x coordinate of the square root of 2 over 2 and a y coordinate of the square root of 2 over 2. But in quadrant 4, they're both negative. So it's negative square root of 2 over 2 and negative square root of 2 over 2. I'm just taking what I learned about the 45, 45, 90 degree triangle in quadrant 1, and I'm moving it over to the other quadrants. Okay, and in quadrant number 4, the x is positive and the y is negative. So y is negative, x is positive. Okay, so I'm going to take this next angle, the 315, because the reference angle for that is a 45 degree angle. Okay, and a 45 degree angle has an x coordinate of the square root of 2 over 2. And a y coordinate of the square root of 2 over 2. But I'm in quadrant 4 now, where that y is negative. Okay, awesome. Okay, and of course, x and y are both positive in quadrant 1. Okay, so we just filled in all of the 45 degree angles in our unit circle. Okay, now let's talk about our 30 degree angles. Okay, so I'm going to scooch back down here a little bit. Okay, this is our basic 30, 60, 90 degree right triangle. Okay, now it has a hypotenuse of 2, and in our unit circle, we can't have a hypotenuse of 2. We need the radius to be 1. So what we have to do is we have to divide everything by 2. So that now our triangle that we can draw into our unit circle has a 30 degree angle, has a hypotenuse of 2 divided by 2, which is 1. The y coordinate is 1/2, and the x coordinate is the square root of 3 over 2, just like that. Okay, so now let's go up here to our 30 degree angle. Okay, and we had, just looking again, an x, a square root of 3 over 2, and a y of 1/2. Square root of 3 over 2, and a y of 1/2. Those are the coordinates of the terminal point of our 30 degree angle. Okay, so now if we look at our 150 degree angle, okay, the reference angle for that is 30 degrees. Okay, and our 30 degree angle, we just figured it out, has an x of the square root of 3 over 2 and a y of 1/2. Only in quadrant 2, the x is negative right? So we need to try to squish a negative sign in there. Let me give myself a little more space. That needs to be a negative square root of 3 over 2. There we go. All right. So now we're going to head over to the next one, which is that 210. 210 degrees also has a reference angle of 30. Okay, so that means it's going to be the square root of 3 over 2 and 1/2, but in quadrant 3, both are negative. So this is going to be negative square root of 3 over 2 and negative 1/2. Okay, nice. Look, we're almost done with our unit circle. Moving right along. Okay, next one we're going to do is 330 degrees, because 330 degrees have a reference angle of 30. Okay, so that means its x and its y are going to be the square root of 3 over 2 and 1/2. And in quadrant 4, the negative one is the y. So there we go. There's our coordinates for that angle. Okay, that leaves us with just 4 angles to go and we're done. Okay, the next one is the 60-degree angle. Okay, same thing as the others. We can't have an hypotenuse of 2 in a unit circle. The hypotenuse needs to be 1, the radius. So you divide everything by 2. Okay, so that we can write it in our unit circle. Okay, so our unit circle 60-degree angle has a hypotenuse of 2 divided by 2, which is 1, an x value of 1/2, and a y value of the square root of 3 over 2. Okay. Notice on that one, the x and the y are the same as the 30-degree angle. We're just switching the x and the y. It's square root of 3 over 2 and 1/2, just reversed. Okay, so now we're going to come up here to our quadrant 1, and our 60-degree angle has an x value of 1/2 and a y value of the square root of 3 over 2. Just the flip of the 30-degree angle. Okay, so now when we go over here to 120 degrees, the angle that has a reference angle of 60, right? We can take the 60-degree angle from quadrant 1, and I can put those values here, right? Which was 1/2 and the square root of 3 over 2, except that in quadrant 2, the x is negative. So now it's going to be negative 1/2 and a positive square root of 3 over 2. Okay, that's our 120-degree angle. All right. Next, we're going to head down to here to our 240-degree angle, because that has a reference angle of 60. Okay, so we're going to take that same thing, 1/2 and the square root of 3 over 2. Only in quadrant 3, they're both negative. So negative 1/2, negative square root of 3 over 2. Okay, and then the last angle on our unit circle, and we're done with our unit circle. The last one is going to be 300, right? 300 degrees also has a reference angle of 60. So that means we're going to use those same coordinates, 1/2 and the square root of 3 over 2. Only in quadrant 4, the y is negative, right? So 1/2 and negative square root of 3 over 2. Okay, and there you go. We filled everything in. Okay, our completed unit circle. We made it. We now know how to derive a unit circle. Good job, you have done it. Thank you, and you've made it. That's the best thing through pre-calculus.